at what we call Newton's second law. Newton's second law. Very important. And what does the law say? It says F net equals mass over acceleration, mass of an object. So now, please note that this formula, or the second law of Newton, is not F equal to ma, but F net. There's a reason why they've got a net there. I'll explain just now. Now, what the law basically says, right? It says if you've got an object, anything, could be a person, it could be a brake, it could be a trolley, whatever, and you apply a force onto it, ne? The object will move in the direction of the net force. That's what it means. So if I apply a force of 15 newtons in this direction, let me fix my handwriting. If I apply a force of 15 newtons in this direction, obviously the object will sort of, feel that force in that direction. But if I apply a force of 50, the F net will be 50. If I apply a force of 50 and there's a frictional force of 10 newtons on the floor, then it means that the law says that the object will accelerate in the direction of the net force. So now, what is the direction of the net force here? If our right direction is, or rather the direction to the right is positive, then the direction to the left will be negative. So therefore, the net force will be 40. So positive 40, which would then mean that the object would accelerate in the direction of the net force, which is the right. That's what the law says. Are we all happy? Do you understand the law, not only the formula, but the law, the interpretation of the law itself? Yes? Proper stuff, proper stuff. Sharp, sharp. So now, then I said this word net is very, very important. As a scientist, as a mathematician, because you guys are going to be scientists next year, mathematician, wherever you are, you need to have attention to detail. The finer print, you need to have attention to that. So this word net, a scientist didn't just wake up in the morning, or Newton, and just put the word net. There's a meaning to it. All right. So consider this object here, a trolley, pushed with a force of 15 newtons to the right. Let's take the direction to the right as positive. And then this object is moving on sand, like this trolley is moving in sand. So obviously this sand This sand restricts movement or inhibits movement. So therefore there would be some sort of frictional force on the ground. So let's just assume that the frictional force on the ground is 10 newtons to the left, or negative 10, right? Then these are the two forces acting on this object. Another force acting on this object would be normal force, but I'm going to come to it shortly. You guys realize that because this object has mass, this trolley, it's weighing on this ground. If this, let's just say the ground was your back, like someone put like a trolley on your back, you'd feel the weight of the trolley, right? That weight is due to gravity, right? So it's due to gravity. It's mg. So it's the mass of the object times 9.8. That is the weight of that object onto the, like, on the floor. Or you could also say that is the force that the object applies onto the floor. Now, Newton's third law says, because we're looking at the second, but the third law says, if an object exerts a force to another object, let's just say a force of 10 newtons, that other object will exert the same force, but in the opposite direction. So now, since this what do you call it? This object exerts a force of mg, then the floor will also exert a force of mg, but in the opposite direction. So those two forces will cancel each other out. Now, if you ever ask to find, or rather to use this formula F net, you need to take into account all of the forces that are acting on the object. So a practical example, let's just say this thing weighed 2 kgs, okay? Then they ask us to find the acceleration of this trolley, right? So we are going to use the formula F net, second law. Why? Because we have mass, we're looking for acceleration, we have forces. So that's why we are able to use that formula. So now let's go ahead and substitute. Our mass is 2 kg, so it's going to be 2a on the right hand side. What about our F net? F net is all of the forces that are acting on the object. So the best way, or the most easy way to get to the bottom of this is if you use a free force diagram. What do they call it? Free body diagram, that. Ne? So yeah, essentially that. So we know what the forces acting on this object are: force applied, frictional force, you must indicate with the size of the force, like the size of the arrow must reflect the size of the force. Then we also have normal force, that is the force the ground is applying onto the object, and then force of gravity, that is the force the object is applying onto the ground. So we have 4 forces. So under FNet, we're going to incorporate all of those forces. So we've got force applied plus force of friction plus force of gravity plus normal force. Now, force applied is 50 newtons because we took the direction to the right as positive. Frictional force is negative because it's opposing. These two, you're not going to put them because they are there, but you're not going to include them because they cancel each other out, basically, because they're the same. So you can just leave that out and have 2a. And then obviously this will give you 40 equal to 2a. And then we divide both sides by 2, then your acceleration will be 20 square meters per second. So do you guys see how what this thing means, this net thing means? Yes, gents? Delicious, ne? Confirmation, just to make sure. Lulama is still there, boss? Just to make sure that all of you can still hear me. Lulama can't. Lulama, are you there, boss? I just trust that he's there. Maybe he's got network problems, but I just hope. All right, proper stuff. Sharp. So yeah, remember what we're doing in this session, just so you guys don't lose track of what's going on. This session is on momentum, and then we said that momentum follows this formula: P equal to mv, where the P represents the momentum, small letter p, m mass, v velocity. That is what momentum is. We did calculations on that. We also did calculations on momentum before and momentum after. We sort of understood what's happening there. Then after that, I then introduced this Newton's second law. There's a reason why I introduced this Newton's second law of F net equals to ma. This is why I introduced that. I'm gonna rewrite it there. Sharp. So we can further simplify this formula to, we know the formula for acceleration from the formula sheet, it is delta v over delta time, right? We continue. Mass equal to change in velocity. Change in anything is usually final minus initial. So it's going to be final velocity minus initial velocity over change in time. Final time minus initial time, but we don't really need this at the moment. So we multiply out the m. So we've got mvf, mv initial over delta time. Now, mv is the formula for momentum. So this will be momentum before minus, momentum after minus momentum before. That is change in momentum. So this is what we call, I'm not sure, this is what we call, let me just quickly explain. This is what we call Newton's second law, right? This is what we call Newton's second law of momentum. So this is change in momentum divided by change in time. So this is called Newton's second law of momentum. Still Newton's second law, but we just sort of represented it in a different way. This is the primary one, you know. Are we all happy with Newton's second law of momentum? Proper stuff. Now I'm going to give you guys an activity. Very interesting. You're going to apply this Newton's